Hi, welcome back. We're about to finish here. So our center, yeah, that makes sense. Radius 4. This would be a possible answer. Additionally, a lot of students like to go ahead and write it a different way. They'll turn out and write this 16, and I would agree with that as a possible answer as well. This would be an answer, and this is an answer. And in fact, technically, this is an answer because the radius squared, this is a true statement right there. But we also have some more information. Okay, so now, this is interesting. We talked a little bit in one class about these tangents. I'm going to maybe go down to this one. I think this is the one we've talked about the most. So remember when we did RDCA? They're saying the area is 25 pi. Well, another way to write 25 is the number 5 times 5 pi. Isn't that just the radius times pi? And the last I checked, the area of a circle is pi radius squared. So in a way, if we know the area of our circle is 25 pi, going backwards, we know our radius has to be 5. Okay, and this is something we've been working on. So one possible answer for 14 would be x minus 0 squared plus y minus 13 squared equals the radius squared. We also, though, using those same patterns, does that make sense? Now we can also we have additional information here, so another way we could write this is x squared, because that's also a true statement. These are the same thing. We could write this one in the same way. I didn't really change that one, but we also know now that the radius is 5, so that would be 5 squared. Now, last but not least, a lot of people are going to want to rewrite it again. I'm okay. Any of these are correct, but some students would want to go ahead and put equals 25, which is a true statement. So working backwards, the center would be that, and a radius of 5 would give you an area of 25 pi. 100% agree. Now, depending on your class, we did a couple of these tangents. So let's look at this tangent. If the center is here and it's tangent to x plus 13. Well, let's see what that would be. I kind of have to come up with a little sketch, and I may need to go back to my piece of paper from earlier. So I'm going to do question number 12. The center is 10, negative 14, and it's tangent to x equal 13. Okay, so let's figure out what x is 13. When x is 13, this line says, if you're graphing it, you need a couple coordinates, right? It says x is 13, and y could be whatever you want it to be. Right? So, nope, we don't have that. This could be any number because x is 13 and only 13. So we could graph the point 13, 0 or 13, 5. It doesn't matter. That's x is 13. Hopefully that helps. So if I'm just going to kind of pretend to draw that, x is 13, so I'm just going to go over 13. And maybe up 5 or over 13 and not up at all. So this is a graph of the line x is 13. Okay, now if you're tangent to that, let's say I went over 13. This one I went over 10 and down 14. So then I went over 10, down 14. So the distance between the 10 and the 13 is just the number 3. So it looks like I kind of already know that the radius would have to be 3 because if the center is at 10 and this line is at 13, then the distance between those two numbers is just 3. And now I have enough information to make the graph. Okay, so here the radius is 3 because 13 minus 10 is 3. And the center, so I have all the information I need to write the graph. X minus 10 and y plus 14 would be the radius squared. Another way, if you want, you could write it like this, and you could graph it, and Desmos would help you understand why your answer is this. Sweet. Now, let's look at this one. It says if the center's at -13, so again, it's just a quick sketch, back 13, down 16, there's my center, and then a point on the circle is -10, down the same 16. So the center is here, and the point on the circle is there. And it looks like, same kind of idea here, those would just be 3 apart. This is my center, -13, -16. The point on the circle, -10, -16. So these would have to be 3 apart because that's how far apart they are. So I think that that means if the center's there and the edge of the circle is there, then that would be my radius 3. And so really, it's the distance between these 2 points. The distance between that number and that number on a number line is just the number 3. So I have enough to make an equation. The center would be this, and this, and with my radius 3, remember this is radius squared. Another way to write it would be to actually write the number 9, and that would be another correct answer. Good job. All right. Here it says a center lies in the first quadrant, tangent to x and tangent to y. Oh boy, a lot going on there. So I'm going to use this piece of graph paper because I didn't use it very well to graph this. So if x is 8, you go over, and to graph this, x is 8, that would be right here. X is 8. That's the graph of all the values where x is 8. Now here, I can graph this, y is 3. So this would be a graph of y is 3, and again, you can put that in Desmos. So now, the center lies in the first quadrant, tangent to all of these. So x is 14. X is 14. So I gotta go all the way 8, 9, 10, 11, 12, 14. X is 14. So they're saying, if I keep on going, that the circle is tangent to all these lines, and it's here in this first quadrant. So that's kind of interesting, isn't it? It looks like my circle goes from 8 to 14, and it's somewhere in the middle of that. So using our brains here, or maybe a little bit of averaging, but what's the average of 8 and 14? So 8 plus 14 divided by 2 is 11. Okay, cool. So the number 11 would be halfway in between there, and so our center would have to be at 11, and all the way across there, so 8, 9, 10, 11, 9, 10, 11, 12, 13, 14. So it looks like my radius here has to be 3. Because to get from 8 to 14, you would have to go 3 to the middle and 3 more. And so I got to keep going up 4. This would be my center right there. Pretty interesting question. So my center would be 3 up from this number 3. So 3 up from 3 would be y value 6. Cool. So looking at this question, my circle here would be radius 3, and my center is at 11, 6. So notice it was the distance between these two, but that created my full diameter. So my full diameter, 14 minus 8, was 6. And half of 6 was 3 because that would have been my radius. Let's write our equation here. All right, pretty neat. Radius squared would be 9. Good job. So my diameters are at 18, and so that's all the way across. That's kind of like what happened there. So I'm gonna have to find out how far apart they are and divide that in 2. So let's maybe do this one. I have a center at -13, -16, and a point on the circle at -10, -16. So once again, it looks like the radius is 3, and I have my center. So I can just go ahead and write that equation. Oh, I already did. Oops. So I have done all these over here. Sorry about that. I only have this one left. Okay, so with this one as my only one left, I'm going to graph it and see what strategy works here. I got 18, -13, 4, -3. So that's my diameter. So somewhere in the middle here is got to be my center, and I have to have a center in order to make this. So you have to use the midpoint formula. Okay, that's you add the 2 values and divide by 2. And you add these 2 y values and divide by 2. So I end up getting 11. Okay, so I can do this side, x minus 11 squared, y plus 8 squared. Find out in class what I got for the radius. Thanks for joining us.